let yourself settle in for a moment. Feel the surface beneath you, supporting your weight completely. There's nowhere you need to be, nothing you need to do. Just breathe. A slow breath in, feeling the cool air fill your lungs, and then release it gently, letting any tension flow out with it like water finding its way downstream. Tonight, we're going to explore something you've probably seen countless times, something so familiar that you might think you know it well. But I promise you, by the time our journey ends, you'll see it with entirely new eyes. We're going to discover the true size of the Orion constellation, and in doing so, we're going to venture into distances so vast that they challenge everything we think we understand about space and size and the universe itself. But here's the beautiful thing. You don't need to remember every number or grasp every concept. Just let the story wash over you like gentle waves on a quiet shore. Let the images form in your mind. Let the wonder seep in slowly, and if you drift off along the way, that's perfectly fine. That's exactly what this is for. Before we begin, if you're enjoying this journey into the cosmos, I'd love it if you could take a moment to like this video and subscribe to The Science Pillow. It helps more people find these calming explorations of the universe, and it means the world to me. Your support makes it possible to keep creating these peaceful voyages through space and time. Now, close your eyes if you'd like, or let them rest softly on a distant point. We're about to embark on a journey through one of the most magnificent sights in the night sky, a constellation that has guided travelers, inspired poets, and fired imaginations for thousands of years. We're going to discover just how big Orion really is, the familiar hunter in the sky picture. A winter evening. The air is crisp and cold, the kind of cold that makes your breath visible in small clouds. You step outside, away from the warm glow of indoor lights, and you look up. The sky is clear, scattered with countless points of light, and there, impossible to miss even if you tried, is Orion. You've probably seen it before. Most people have, even if they don't know many other constellations. There's something about Orion that catches the eye immediately. Perhaps it's the distinctive pattern, that unmistakable hourglass shape formed by bright stars arranged almost like they were placed there deliberately. Perhaps it's the 3 stars in the middle, lined up in a perfect row, forming what everyone calls Orion's belt. Or perhaps it's simply the brightness of it all, the way these stars seem to shine more boldly than their neighbors. Orion spans an area of 594 square degrees of the night sky. Now, that number might not mean much at first, so let's put it in perspective. The entire celestial sphere, all the sky you could possibly see from every point on Earth combined, covers about 41,000 square degrees. Orion takes up just over 1% of that, making it the 26th largest constellation out of the 88 officially recognized patterns in the sky. But size on the sky doesn't quite capture what we see when we look at Orion. What matters more is the impression it makes, the way it dominates the evening sky during winter months in the northern hemisphere. From horizon to horizon, Orion stretches roughly 30 degrees in height and about 20 degrees in width. To give you a sense of that scale, your closed fist held at arm's length covers about 10 degrees of sky. So Orion, from top to bottom, spans about 3 fist widths. It's substantial. It's noticeable. It's grand. At the top left shoulder of the celestial figure, you'll find Betelgeuse, glowing with a distinctive reddish-orange hue that sets it apart from the other bright stars around it. This is Alpha Orionis, though curiously, it's only the second brightest star in the constellation. At the bottom right, marking what would be Orion's left foot if you imagine him facing you, shines Rigel, a brilliant blue-white star that usually outshines Betelgeuse despite having the designation Beta Orionis. The other shoulder, at the top right, is marked by Bellatrix, another bright blue-white star, and at the other foot, bottom left, you'll find Scythe, completing the rectangle that forms Orion's body. These stars give Orion its hourglass appearance, two triangles meeting at the narrow waist where that famous belt lies. And oh, that belt. 3 stars, Alnitak on the left, Alnilam in the middle, and Mintaka on the right, arranged in such a perfectly straight line that it seems almost unnatural. They're evenly spaced, or at least they appear to be from our vantage point. They're roughly the same brightness. They form what is probably the most recognizable asterism in the entire night sky, a pattern that humans across virtually every culture have noticed and named. Below the belt hangs Orion's sword, a vertical line of stars and fuzzy patches extending downward. The middle star in this sword isn't quite a star at all. Even to the naked eye, it looks slightly fuzzy, slightly smudged. Through binoculars or a small telescope, this fuzzy patch reveals itself as something extraordinary. The Orion Nebula, one of the most spectacular stellar nurseries in our part of the galaxy, a place where new stars are being born. Ancient civilizations saw different things in this pattern. The ancient Egyptians saw it as Osiris, god of the afterlife, while the ancient Greeks saw Orion the hunter, a giant of mythology who boasted he could hunt any animal on earth. The Babylonians called it the true shepherd of Anu, while various Native American tribes saw different figures, from a canoe to 3 sisters. Australian Aboriginal peoples saw 3 men in a canoe, or 3 brothers, or 3 fishermen, depending on the specific culture. But regardless of what people called it, or what stories they told about it, virtually every culture that could see this part of the sky noticed it. There's something universal about the pattern, something that draws the human eye and fires the imagination. It's bright, it's distinctive, and it appears at the same time each year, rising in the east in early evening during autumn, and climbing high in the southern sky during winter evenings. For observers in the northern hemisphere, Orion dominates the southern sky from December through February, with January being the peak viewing month. For those in the southern hemisphere, Orion appears in the northern sky during their summer months, upside down from the northern perspective, but no less magnificent. The constellation is visible from virtually everywhere on Earth, from latitudes as far north as 85 degrees to as far south as 75 degrees. Only the extreme polar regions miss out on this celestial spectacle. What you're seeing when you look at Orion is light. Light from stars. Light that has traveled through the vacuum of space for years, for decades, for centuries even, before finally entering your eyes. And this is where things start to get interesting, because the light from these different stars left them at very different times. The constellation you see is not a snapshot of how these stars are right now. It's a collection of images from different eras, a patchwork of the past. When you look at Orion, you're not looking at a single thing at a single moment in time. You're looking at a carefully arranged illusion, a trick of perspective that makes stars separated by unimaginable distances appear to be part of a cohesive pattern. From where you stand on Earth, Betelgeuse and Rigel appear to be part of the same structure, 2 corners of the same celestial figure. But in reality, They exist in completely different neighborhoods of our cosmic landscape, separated by hundreds of light years of empty space. This is the beautiful lie that constellations tell us. They group stars together based on how they appear from our specific vantage point, from our particular planet orbiting our particular star in our particular corner of the Milky Way. Move to a different star system, and the constellations would look completely different. The hunter would vanish, his shape scattered and meaningless, and new patterns would emerge from the seemingly random scattering of lights. So, when we ask, how big is Orion, we're really asking two very different questions. One is simple. How much of our sky does it cover? We've answered that. 594 square degrees, about 30 degrees tall, visible and magnificent. But the other question is far more profound. What is the actual, physical, three-dimensional size of the region of space that contains these stars? How much of the universe does Orion really occupy? To answer that question, we need to stop thinking about Orion as a pattern on the dome of the sky, and start thinking about it as it truly is. A collection of unrelated stars at vastly different distances, scattered through a volume of space so enormous that it defies easy comprehension. We need to venture into the realm of the light year, that strange unit of measurement that describes not space but time, or rather, the distance that light can travel in a year. And we need to meet the stars of Orion not as points of light in a pattern, but as individual worlds, each one a sun in its own right, each one separated from its neighbors by distances that make the space between planets look like nothing at all. The illusion of proximity. There's a fundamental illusion at work when you look up at the night sky, one so basic that it's easy to forget it's happening at all. Your brain, evolved to understand the three-dimensional world around you, flattens the sky into 2 dimensions. The stars appear to exist on a surface, a celestial dome arching overhead, with some stars brighter than others but all seemingly at the same distance from you. This made perfect sense to ancient observers. For thousands of years, people genuinely believed that stars were lights attached to a rotating sphere, a crystalline firmament that turned above the earth. The stars were all equally distant, differing only in their brightness, and they moved together as this great sphere rotated. It was a beautiful model, elegant and intuitive, and utterly wrong. The truth is stranger and far more magnificent. The stars you see when you look at Orion aren't on a surface. They're scattered through an enormous volume of three-dimensional space, and the distances between them dwarf anything in our everyday experience. Some stars that appear right next to each other in the sky might be separated by hundreds of light years, while others that look far apart might actually be relatively close neighbors. To understand what a light year means, we need to start with light itself. Light is the fastest thing in the universe, racing through empty space at about 186,000 miles every single second. In the time it takes you to snap your fingers, light could travel from New York to Los Angeles and back twice with time to spare. In 1 second, light circles the Earth's equator more than 7 times. And yet, even at this incomprehensible speed, it takes light more than a second to reach us from the moon. It takes about 8 minutes for light to travel from the sun to Earth. If the sun suddenly vanished, we wouldn't know about it for 8 minutes because that's how long it would take for the change to reach us. We'd still see the sun in the sky, still feel its warmth, and then, 8 minutes later, everything would go dark and cold. The nearest star to our sun, a small red star called Proxima Centauri, is about 4.2 light-years away. That means the light you would see from that star left it 4 years and 2.5 months ago. When you look at Proxima Centauri, you're looking at the past, seeing that star as it was when the light began its journey. Now, the stars of Orion are much, much farther away than that. Even the closest stars in the constellation are more than 100 times more distant than Proxima Centauri, and the farthest are more than 400 times as far. These aren't neighboring stars. These are stars scattered across vast reaches of our galaxy, appearing to share a pattern only because of where we happen to be standing. Let's think about this in terms of a familiar analogy. Imagine you're standing in a vast, dark field at night. In the distance, you see 3 lights that appear to be in a straight line. From where you stand, they look evenly spaced, like streetlights along a road. But if you could suddenly fly upward and look at those same 3 lights from above, you might discover that one is a flashlight on a fence post 50 feet away. Another is a porch light on a house a quarter mile away, and the third is a distant water tower light 5 miles away. They only appeared to be in a line from your specific vantage point. From anywhere else, the pattern would look completely different. This is exactly what's happening with Orion's belt, those 3 stars that look so perfectly aligned. From Earth, they appear to form a straight line, evenly spaced and similar in brightness. But in 3-dimensional space, they're at vastly different distances from us, and they're not particularly close to each other either. Alnitak, the leftmost star in the belt, the one that marks the eastern edge, lies approximately 800 light-years from Earth. Now, 800 light-years is a distance that's difficult to conceptualize. If you could travel at the speed of light, it would take you 800 years to get there. All of recorded human history, from the ancient civilizations of Mesopotamia to the present day, spans only about 5,000 years. You could fit the entire journey to Alnitak into human history more than 6 times. In the middle of the belt shines Alnilam, and this star is much farther away. Estimates place it at roughly 2,000 light-years from Earth. The light you see from Alnilam tonight left that star around the time of the Roman Empire, when Julius Caesar walked the earth and the Library of Alexandria still stood. That's how far away Alnilam is. The light has been traveling for 2,000 years to reach your eyes. And Mintaka, the rightmost star of the belt, lies at approximately 900 light-years away. Closer than Alnilam, but farther than Alnitak. So, these 3 stars that look like they're right next to each other, evenly spaced in a perfect line, are actually separated by vast gulfs of space. Alnilam is more than 1,000 light-years farther from us than Alnitak, and yet they appear to be the same distance away. But it gets even more interesting when you consider the distances between the stars themselves, not just their distances from us. If you were somehow standing on a planet orbiting Alnitak, and you looked toward Alnilam, you'd see it not as a nearby neighbor, but as a distant star, hundreds of light-years away. These stars aren't close to each other. They just happen to lie roughly along the same line of sight from our perspective here on Earth. The same is true for all the stars in Orion. Betelgeuse, that red giant at the hunter's shoulder, sits about 548 light-years from Earth. Rigel, the blue supergiant at the foot, is approximately 860 light-years away. Bellatrix is roughly 250 light-years distant, while Saiph is about 720 light-years away. These stars range from about 250 to 2,000 light-years from Earth, scattered across a depth of 1,750 light-years or more. To visualize this, Imagine you could somehow shrink space so that 1 light-year became 1 foot. Even at this tiny scale, the stars of Orion would be scattered across a region 250 feet deep. If you put Bellatrix at one end of a football field, Alnilam would be more than 3 football fields away, off in a completely different direction. And that's with each light year compressed down to just 1 foot. At the true scale, the volume of space containing the stars we call Orion is almost incomprehensibly large. If you drew a sphere that enclosed all the bright stars of the constellation, that sphere would have a diameter of about 2,000 light-years. To put that in perspective, the entire Milky Way galaxy is roughly 100,000 light-years across, so Orion's stars occupy a region about 2% the diameter of the entire galaxy. That 2% might not sound like much until you realize that the Milky Way contains somewhere between 200 billion and 400 billion stars. A sphere 2,000 light-years across within the galaxy would contain tens of billions of stars, the vast majority of which are too dim for us to see with our naked eyes. We see only the handful of especially bright stars, the ones luminous enough to catch our attention across those enormous distances. And here's something even more mind-bending. If you were to travel from one star in Orion to another, the constellation pattern would disappear along the way. When you're standing on Earth, Betelgeuse and Rigel appear to be part of the same structure. But if you were to travel toward Betelgeuse, it would gradually brighten and grow in your view while the other stars would shift positions, the pattern distorting and changing. By the time you reached Betelgeuse, Orion as we know it would be gone. The hunter would have scattered into meaningless points of light, and new patterns would have emerged from stars that aren't even part of Orion from our earthly perspective. From Betelgeuse, looking back toward Earth, our sun would be just another faint star, indistinguishable from billions of others. You wouldn't be able to pick it out without knowing exactly where to look. The constellations we see from Earth, patterns like Orion that seem so permanent and real, exist only for us, only from our vantage point. They're a function of perspective, beautiful accidents of geometry. This is what makes the question, how big is Orion, so fascinating. In one sense, Orion is just a pattern, a shape drawn by human imagination connecting dots in the sky. It has no physical existence, but in another sense, Orion is a region of space 2,000 light-years across, containing billions of stars, a vast, three-dimensional landscape that we glimpse from one tiny corner. The answer to the question depends on what we mean by Orion in the first place. Orion's belt, 3 stars, 3 worlds. Let's focus our attention on those 3 stars in the middle, that famous belt that makes Orion so easy to identify. These 3 points of light have fascinated humanity for thousands of years. The ancient Egyptians called them the 3 gods. The ancient Arabs called them the string of pearls. Cultures around the world have noticed them, named them, told stories about them. They appear so obviously connected, so clearly part of a single structure, that it seems natural to think of them as a unit. But they're not a unit. They're 3 completely separate stars, each one vastly different from the others, each existing in its own neighborhood of space, each with its own unique story to tell. Let's start our journey at Alnitak, the easternmost star of the belt, the one on the left as you look at Orion from the northern hemisphere. The name Alnitak comes from Arabic, from the phrase an-nitak, meaning the girdle. It marks the edge of the belt, the edge of the girdle that Orion wears across his waist. But Alnitak isn't actually a single star. It's a triple star system, 3 stars bound together by gravity, orbiting their common center of mass in a cosmic dance that has been going on for millions of years. The brightest of these 3 stars, the one we call Alnitak A, is what astronomers classify as a blue supergiant. It's a massive star, somewhere between 20 and 30 times the mass of our Sun, and it's incredibly hot, with a surface temperature of roughly 30,000 Kelvin. For comparison, the surface of our Sun is about 5,700 Kelvin, already hot enough to vaporize any material we know of. Alnitak is more than 5 times hotter than that. At such extreme temperatures, the star glows intensely blue-white, pouring out tremendous amounts of ultraviolet radiation that our eyes can't see but that contributes to the star's total energy output. And that energy output is staggering. Alnitak is approximately 100,000 times more luminous than our Sun. If you were to somehow replace our Sun with Alnitak, the Earth would be instantly incinerated, vaporized by the flood of radiation. Even at Alnitak's distance of about 800 light-years, we can see it clearly, shining as one of the brightest stars in the night sky. This star is enormous. Its radius is about 20 times that of the Sun, which means if you could place Alnitak at the center of our solar system, its surface would extend past the orbit of Mercury and almost reach Venus. And yet, for all its size, Alnitak is young. It's only a few million years old, a mere infant compared to our Sun's age of 4.6 billion years. Stars like Alnitak don't last long. They burn so hot and so bright that they consume their nuclear fuel at a prodigious rate. Where our Sun will shine for about 10 billion years total, Alnitak will last only a few million years before it exhausts the hydrogen in its core and begins the final stages of its life. Eventually, it will explode as a supernova, a catastrophic detonation that will briefly outshine entire galaxies. Orbiting close to this blue supergiant is Alnitak AB, a smaller companion star, itself still several times the mass of the Sun. These 2 stars are so close together that they orbit each other every 7 years or so, locked in a gravitational embrace. And farther out, about a quarter of a light-year away, orbits a 3rd star, much fainter than the 2 inner stars but still part of the same system. Now, let's move to the middle of the belt, to Alnilam. This star's name comes from the Arabic phrase an-nizam, meaning string of pearls, referring to the belt as a whole. From our perspective, Alnilam looks quite similar to Alnitak. It's only slightly brighter, shining with an apparent magnitude of about 1.69 compared to Alnitak's 1.74. To the naked eye, they're nearly indistinguishable in brightness. But Alnilam is much, much farther away. While Alnitak sits at 800 light-years, Alnilam lies at roughly 2,000 light-years from Earth. The fact that these 2 stars appear nearly the same brightness despite Alnilam being more than twice as far away tells you something important. Alnilam must be intrinsically much brighter than Alnitak. And it is. Alnilam is a blue supergiant, similar in some ways to Alnitak, but even more extreme. This star is about 375,000 times more luminous than the Sun, almost 4 times brighter than Alnitak. If you could somehow place Alnilam and Alnitak side by side at the same distance from Earth, Alnilam would utterly outshine its companion. Alnilam is also larger. Its radius is estimated at about 42 times that of the Sun, more than twice the size of Alnitak. If you placed Alnilam at the center of our solar system, its surface would extend well past the orbit of Mercury and reach about halfway to Venus. This is a star on a scale that's difficult to truly comprehend. What makes Alnilam particularly interesting to astronomers is that it's at a special stage in its life. It's transitioning from the main phase of stellar life, where it fuses hydrogen into helium in its core, toward the later stages where it will begin fusing heavier elements. This transition makes the star unstable, causing it to pulsate slightly, swelling and shrinking over periods of days and weeks. These pulsations make Alnilam what's called an alpha Cygni variable, a type of star that changes slightly in brightness over time. The star is also losing mass at a tremendous rate. Its stellar wind, a stream of particles blown off its surface by the intense radiation pressure, is carrying material away into space. Eventually, over the next few 100,000 years or so, Alnilam will swell into a red supergiant, similar to how Betelgeuse appears now, before finally detonating as a supernova. Unlike Alnitak, Alnilam appears to be a single star, not a multiple system. It's relatively rare for such massive stars to be truly alone, as most form in binary or multiple systems, but Alnilam seems to be the exception. It shines in isolation, a solitary giant blazing in the darkness of space. Now let's travel to the western end of the belt, to Mintaka. This star's name comes from the Arabic Mantaka, which also means belt or area. Mintaka is special for several reasons, one of which is its position in the sky. It sits almost exactly on the celestial equator, that imaginary line in the sky that lies directly above Earth's equator. This means Mintaka rises almost exactly due east and sets almost exactly due west, regardless of where you're observing from. For ancient navigators, this made Mintaka a useful reference point. Like Alnitak, Mintaka is not a single star, but a complex multiple star system. In fact, Mintaka is even more complex, consisting of at least 6 stars arranged in an intricate gravitational dance. The brightest component, which provides most of the light we see, is itself a binary system where 2 massive stars orbit each other every 5.7 days. Both of these stars are hot and luminous. The primary is a blue giant, while its companion is somewhat smaller but still much larger and brighter than our Sun. Together, they put out about 90,000 times the Sun's luminosity, making Mintaka one of the most luminous stars in the night sky, even though it appears slightly fainter than its belt companions. Mintaka lies about 900 light-years from Earth, making it the closest of the 3 belt stars, though still incomprehensibly distant by human standards. At this distance, the light we see from Mintaka tonight left the star system around the time Europe was in the Middle Ages, when the Crusades were underway and castles dotted the European landscape. These 6 stars in the Mintaka system are all hot blue stars, ranging from blue supergiants to smaller but still massive blue main sequence stars. The entire system is young, probably less than 10 million years old, and all of these stars are living fast, burning bright, and heading toward dramatic ends. So here we have 3 stars, 3 points of light that appear to form a perfect line in the sky, evenly spaced and similar in brightness. But in reality, they are 3 completely different systems at 3 vastly different distances. They range from 900 to 2,000 light-years from Earth, separated from each other by hundreds of light-years of empty space. If you were standing on a planet orbiting Alnitak, Mintaka would appear as a reasonably bright star, perhaps a bit brighter than the brightest stars we see from Earth, but nothing spectacular. It would be hundreds of light-years away, a distant neighbor rather than a close companion. and Alnilam would be even farther, more than 1,000 light-years distant, still visible but remote. These three stars only appear to be neighbors because of our perspective from Earth. We happen to be positioned such that these three distant stars lie roughly along the same line of sight. Move to any other star system in the galaxy, and this alignment would disappear. The belt would vanish. Orion would cease to exist as a recognizable pattern. And yet, for us, from our vantage point on this small blue planet orbiting an average yellow star in a quiet corner of the Milky Way, these three stars form a perfect belt. They anchor one of the most recognizable constellations in the sky. They've guided travelers, inspired poets, and fired imaginations for thousands of years. The illusion is profound, beautiful, and tells us something important about how we understand the universe. From our perspective, with our eyes, these three stars are connected. They form a pattern. They mean something. The fact that this meaning is a trick of perspective doesn't make it any less real in human terms. We are pattern-finding creatures, and the patterns we find in the sky have shaped our cultures, our stories, our understanding of time and season and space. Orion's belt is not physically real, but it is culturally real, and that counts for something. The shoulder giants, Betelgeuse and Bellatrix. Now, let's raise our gaze from the belt upward to the two stars that mark Orion's shoulders, the upper corners of that hourglass figure that dominates the winter sky. These two stars, Betelgeuse and Bellatrix, are as different from each other as two stars can be, and they beautifully illustrate the range of stellar types that exist in our universe. Let's start with Betelgeuse, that distinctive reddish-orange star at the hunter's left shoulder, at the upper left corner of the constellation as we see it from the northern hemisphere. Betelgeuse is one of the most famous stars in the sky, known not just to astronomers but to anyone who spends time looking at the night sky. Its color alone sets it apart, a warm red-orange glow that contrasts sharply with the blue-white stars surrounding it. The name Betelgeuse is thought to come from Arabic, possibly from Yad al-Jawza, meaning hand of the giant, though the etymology is somewhat uncertain. What is certain is that this star has captivated observers for millennia. Ancient astronomers noted its reddish color and its tendency to vary in brightness, sometimes appearing among the brightest stars in the sky and other times dimming noticeably. Betelgeuse is what astronomers call a red supergiant, one of the largest types of stars known to exist. It's in the final stages of its life, having exhausted the hydrogen fuel in its core and now fusing heavier elements in a desperate attempt to stave off gravitational collapse. This process has caused the star to swell to truly enormous proportions. How enormous? Betelgeuse has a radius of approximately 764 times that of the Sun. Let that sink in for a moment. 764 times. If you could place Betelgeuse at the center of our solar system, where the Sun currently resides, its surface would extend past the orbit of Mars and reach into the asteroid belt. The star would engulf Mercury, Venus, Earth, and Mars completely. We would be inside the star itself, along with everything we've ever known or cared about. And yet, despite this incredible size, Betelgeuse contains only about 16 to 19 times the mass of the Sun. That might sound like a lot, but remember, the star is 764 times wider than the Sun. This means Betelgeuse is extraordinarily diffuse, with an average density far less than Earth's atmosphere. In fact, The outer layers of Betelgeuse are so thin that by laboratory standards they would be considered a near-perfect vacuum. Nevertheless, this tenuous gas is extremely hot, approximately 5,800 degrees Kelvin at the surface, and the star's enormous size means it radiates with tremendous power. Betelgeuse is somewhere between 7,500 and 14,000 times more luminous than the Sun, depending on where it is in its brightness cycle. At its brightest, if you were observing from the same distance we observe our Sun, Betelgeuse would appear about 14,000 times brighter. Now, let's raise our gaze from the belt upward to the two stars that mark Orion's shoulders, the upper corners of that hourglass figure that dominates the winter sky. These two stars, Betelgeuse and Bellatrix, are as different from each other as two stars can be, and they beautifully illustrate the range of stellar types that exist in our universe. Let's start with Betelgeuse, that distinctive reddish-orange star at the hunter's left shoulder, at the upper left corner of the constellation as we see it from the northern hemisphere. Betelgeuse is one of the most famous stars in the sky, known not just to astronomers but to anyone who spends time looking at the night sky. Its color alone sets it apart, a warm red-orange glow that contrasts sharply with the blue-white stars surrounding it. The name Betelgeuse is thought to come from Arabic, possibly from Yad al-Jawza, meaning hand of the giant, though the etymology is somewhat uncertain. What is certain is that this star has captivated observers for millennia. Ancient astronomers noted its reddish color and its tendency to vary in brightness, sometimes appearing among the brightest stars in the sky, and other times dimming noticeably. Betelgeuse is what astronomers call a red supergiant, one of the largest types of stars known to exist. It's in the final stages of its life, having exhausted the hydrogen fuel in its core and now fusing heavier elements in a desperate attempt to stave off gravitational collapse. This process has caused the star to swell to truly enormous proportions. How enormous? Betelgeuse has a radius of approximately 764 times that of the Sun. Let that sink in for a moment. 764 times. If you could place Betelgeuse at the center of our solar system, where the Sun currently resides, its surface would extend past the orbit of Mars and reach into the asteroid belt. The star would engulf Mercury, Venus, Earth, and Mars completely. We would be inside the star itself, along with everything we've ever known or cared about. And yet, despite this incredible size, Betelgeuse contains only about 16 to 19 times the mass of the Sun. That might sound like a lot, but remember, the star is 764 times wider than the Sun. This means Betelgeuse is extraordinarily diffuse, with an average density far less than Earth's atmosphere. In fact, the outer layers of Betelgeuse are so thin that by laboratory standards, they would be considered a near-perfect vacuum. Nevertheless, this tenuous gas is extremely hot, approximately 5,800 degrees Kelvin at the surface, and the star's enormous size means it radiates with tremendous power. Betelgeuse is somewhere between 7,500 and 14,000 times more luminous than the Sun, depending on where it is in its brightness cycle. At its brightest, if you were observing from the same distance we observe our Sun, Betelgeuse would appear about 14,000 times brighter. Betelgeuse lies approximately 548 light-years from Earth. Imagine the scale of that distance for a moment. The light hitting your eyes right now began its journey in the mid-1400s, perhaps just as the printing press was beginning to change the world. This vast distance is also what makes its variability so profound to watch. Because it is a semi-regular variable star, its brightness does not change like a clock, but rather like a beating, irregular heart. These pulsations are the result of internal instability as the star struggles to maintain its structure against its own gravity. When it expands, it cools and dims. When it contracts, it heats up and brightens. In late 2019, the world watched in awe as Betelgeuse dimmed to its lowest level in recorded history, a phenomenon now known as the Great Dimming. For a while, the shoulder of the hunter looked strangely withered, leading many to speculate that the star was on the verge of a supernova explosion. While it eventually returned to its normal brightness, the event reminded us that we are watching a star in the very last moments of its life. Moments that, on a cosmic scale, could mean anything from tomorrow to 100,000 years from now. If Betelgeuse were to replace our sun, our sky would be dominated by a deep, brooding red orb so large it would touch the very edges of our awareness, reminding us of how small our own world truly is in the face of such a giant. Now, shift your focus across the hunter's chest to the other shoulder, the one on the upper right, Bellatrix. The contrast is immediate and striking. Where Betelgeuse is a warm, dying ember of orange and red, Bellatrix is a sharp, piercing needle of blue-white light. Its name comes from the Latin for female warrior, a fitting title for a star that shines with such fierce, cold intensity. Bellatrix is not a supergiant like its neighbor. Instead, it is classified as a hot, luminous giant. It sits much closer to us than almost any other major star in Orion, located roughly 250 light-years away. Even though it is closer, it appears slightly dimmer than Betelgeuse because it lacks that star's impossible bloated surface area. Bellatrix is about 8 times the mass of our Sun, but it is vastly hotter, with a surface temperature of around 22,000 degrees Kelvin. This temperature is what gives it that pristine blue-white hue, a color that signifies extreme energy and youth compared to the aging Betelgeuse. Despite being smaller in the hierarchy of Orion's giants, Bellatrix is still about 6 times wider than our Sun. If it were our Sun, the Earth's oceans would boil away in seconds, and our atmosphere would be stripped by the sheer force of its ultraviolet radiation. What makes the pairing of these two stars so beautiful is the span they create. From our vantage point, they look like 2 anchors for the upper body of the hunter, held at a similar height in the dome of the sky. But this is where the 3-dimensional reality of space shatters the illusion. Bellatrix is nearly 300 light-years closer to us than Betelgeuse. When you look at the shoulders of Orion, you aren't looking at a flat line. You are looking down a long, dark tunnel of space. One shoulder is in the foreground, relatively speaking, while the other is twice as far back into the depths of the galaxy. It is a span of space so deep that it contains thousands of other stars that are simply too dim for us to see, all hidden in the gap between the warrior and the giant. If you were to travel from Bellatrix to Betelgeuse, the journey would take you nearly 3 centuries, even if you could fly at the speed of light. You would pass through a void so quiet and vast that the very concept of a constellation would lose all meaning. By the time you reached the halfway point, Bellatrix would have faded into a tiny point behind you, and Betelgeuse would have grown into a terrifying, pulsating wall of red fire ahead. This is the true scale of the shoulder span. It is not a measurement of inches or miles, but of time and light. It is a gap that defines the very neighborhood of our galaxy. As you look at them tonight, try to see that depth. Don't just see 2 points of light on a flat screen. see the blue-white warrior standing close and the red giant lurking far behind in the darkness. Feel the space between them. Feel the silence of those hundreds of light years that separate these two completely different worlds. It is in this gap, this immense shoulder span, that we begin to realize just how large Orion truly is. It is not a drawing in the sky. It is a cathedral of space, and we are standing at the very entrance, looking in. As we linger on the image of these two giants, let your mind drift even further into the physical reality of what they represent. The space between Betelgeuse and Bellatrix is not just empty void. It is a section of our galactic arm teeming with invisible forces and hidden wonders. To truly understand the scale of Orion, we must keep coming back to that comparison. What if these giants were our neighbors? If Betelgeuse replaced our sun, the view from Earth would be non-existent, for we would be millions of miles deep within its fiery, churning interior. The edge of the star would be where the asteroid belt sits today, making everything from Mercury to Mars a part of the star's own history. From the moons of Jupiter, the sun would no longer be a distant point of light, but a gargantuan red wall filling half the sky. Its heat so intense it would turn icy moons into oceans, and then into steam. This is the sheer, overwhelming presence of a red supergiant. It is a star that has grown so large that it has lost its grip on its own outer layers, letting them drift away like a cosmic shroud. Bellatrix, on the other hand, represents the fast and furious side of stellar evolution. Although it doesn't have the world-swallowing size of Betelgeuse, its energy is far more concentrated. It is a star that is essentially a high-pressure furnace, blasting out blue and ultraviolet light with such force that it pushes away the very gas and dust it was born from. The shoulder span of Orion is thus a bridge between two different fates. On one side, a blue warrior in its prime, burning with a steady but fierce light. On the other, a red giant in its twilight years, unstable and unpredictable. These two stars define the boundaries of the upper constellation, but they also define the life cycle of the universe's most massive objects. They remind us that even the stars have beginnings and ends, though their moments last millions of years. Now, imagine looking at these two stars from a different perspective, perhaps from a planet orbiting a star halfway between them. From that vantage point, the Orion we know would be unrecognizable. The belt would be scattered, and the shoulders would be on opposite sides of the sky. You would be standing in the middle of a cosmic theater, with Bellatrix as a bright blue beacon in one direction, and Betelgeuse as a massive, glowing red lantern in the other. The three-dimensional depth of the constellation becomes even more apparent when we realize that the stars of the belt are actually much further away than either of these shoulders. We are looking past the foreground of Bellatrix and the middle ground of Betelgeuse to see the distant background of the belt stars and the Orion Nebula. This layers the constellation like a painting with immense depth, one that stretches thousands of light years into the dark. This depth is what makes the hunter more than just a shape. It is a volume of space, a giant box of the galaxy that we happen to have a front row seat to. The shoulders, Betelgeuse and Bellatrix, are the top corners of this box. They are the guardians of the hunter's upper half, marking the entrance to the even deeper wonders that lie beneath the belt. As we prepare to move our gaze further down, let the image of these two vast, contrasting suns stay with you. One blue, one red, one relatively near, one much further. Together they hold up the sky of our winter evenings, a pair of giants whose light has traveled through the centuries just to reach your eyes tonight. They are the heavyweights of the northern sky, and their presence is the first true hint of just how large the Orion constellation really is. Take one last breath as you visualize them. The sharp blue needle of Bellatrix and the soft, expansive glow of Betelgeuse, two anchors in the ocean of space. The journey through this shoulder span is a journey through the sheer variety of the cosmos. It shows us that color, size, and distance are all interconnected in a way that creates the beauty we see from our backyard. Without the deep red of Betelgeuse, Orion would lose its warmth. Without the piercing blue of Bellatrix, it would lose its edge. They are a study in opposites, yet they work together to form the most recognizable shoulders in all of human history. As we descend toward the belt and the feet of the hunter, we carry the weight of these giants with us, knowing that we have only just begun to scratch the surface of this cosmic landscape. The hunter is not just a figure of myth, but a collection of physical realities that are so much bigger than the stories we tell about them. We are moving now from the shoulders to the heart of the matter, where even greater distances and more mysterious lights await us in the deep cold of space. Rigel, the foot that outshines the head. Now, let your gaze descend. Leave the broad, powerful shoulders of the hunter and the steady, rhythmic line of the belt behind for a moment. Follow the line of the stars downward, through the dark, cold velvet of the winter sky, until your eyes rest upon a spark of brilliant, icy light at the bottom right corner of the constellation. This is Rigel. In the traditional maps of the stars, it marks the left foot of Orion, planted firmly against the celestial horizon. Its name comes from the Arabic Rigel Jawza al-Yusra, which simply means the left foot of the giant. But do not let its position at the bottom of the figure fool you into thinking it is of secondary importance. In truth, Rigel is the undisputed master of this region of the sky, a star of such staggering power that it outshines even the famous head and shoulders of the hunter. Take a deep, slow breath as you look at that blue-white point of light. It seems so small, so delicate, like a diamond dust grain scattered on a black cloth. But the reality is far more majestic. Rigel is what astronomers call a blue supergiant, and it is one of the most luminous objects in our entire corner of the Milky Way galaxy. While Betelgeuse, the red shoulder we explored earlier, is famous for its size and its brooding red hue, Rigel represents a different kind of celestial royalty. It is a star of pure, focused energy, burning with a temperature and a brightness that challenge our very understanding of what a sun can be. From our perspective on Earth, it usually appears as the brightest star in Orion, even though it is officially designated as Beta Orionis. It is a star that demands to be noticed, a beacon in the deep night that has guided navigators across Earth's oceans for as long as humans have looked to the sky for direction. To understand how Rigel can be the foot that outshines the rest of the body, we must first look at its incredible luminosity. Think of our own sun for a moment, that warm, life-giving orb that provides all the energy for our world. Our sun is powerful, certainly, but compared to Rigel, it is like a single candle standing next to a massive industrial searchlight. Rigel is approximately 120,000 times more luminous than our sun. Let that number settle in your mind like a quiet, heavy snow. 120,000. If you were to take all the light produced by our sun in a single year, Rigel would produce that same amount of light in less than 5 minutes. It is pouring out energy at a rate that is almost incomprehensible, flooding the space around it with a fierce blue-white radiance that extends for billions of miles in every direction. This extreme brightness is the result of Rigel's immense temperature and size. While Betelgeuse is cool for a star, glowing with a reddish heat, Rigel is blisteringly hot. Its surface temperature is roughly 12,000 degrees Kelvin, nearly twice as hot as the surface of our Sun. At these temperatures, matter behaves differently. The light emitted is shifted toward the blue and ultraviolet parts of the spectrum, giving the star its characteristic icy, piercing appearance. It is a light that feels cold to the eye because of its blue tint, but in physical reality, it is a furnace of unimaginable intensity. Every second, Rigel consumes its nuclear fuel with a ferocity that few stars can match, transforming matter into light with a speed that ensures it will live a short, brilliant life. Now, let us consider the physical scale of this giant. While it is not as bloated and gargantuan as the red supergiant Betelgeuse, Rigel is still a titan by any human standard. It has a radius of approximately 74 solar radii. To visualize this, imagine our Sun as a small marble. In this comparison, Rigel would be a sphere nearly 7 feet across. If you were to place Rigel at the center of our solar system, where the Sun sits today, its surface would extend far beyond the orbit of Mercury. It would fill a significant portion of our inner sky, an enormous, blinding wall of blue fire. The Earth would not survive such a neighbor. The sheer pressure of Rigel's light and the intensity of its heat would strip away our atmosphere and melt our crust in an instant. We are fortunate that this giant is kept at a safe, respectful distance, allowing us to admire its beauty without being consumed by its power. That distance is itself a staggering concept to contemplate. Rigel lies approximately 860 light-years from Earth. Think back to the light you see tonight as you look at the Hunter's Foot. That light began its journey through the void over 8 centuries ago. It left the surface of Rigel in the late 12th or early 13th century. As that light traveled through the silent, empty reaches of the galaxy, empires on Earth rose and fell. The Middle Ages passed into the Renaissance. The Industrial Revolution changed the face of our planet. The modern age of technology began. All that time, through all those generations of human history, that specific beam of light was racing toward you at 186,000 miles per second, never stopping, never slowing, until it finally reached your eyes this evening. When you look at Rigel, you are not seeing it as it is now, but as it was in the time of the Crusades and the building of the great cathedrals. You are looking at a ghost of the past, an ancient signal from a star that may have changed significantly in the 800 years it took for the message to arrive. As you settle deeper into this thought, let your mind explore the complexity of Rigel. To our eyes, it appears as a single, solitary point of light, a lonely monarch at the foot of the constellation. But like so many things in the universe, the closer we look, the more intricate the reality becomes. Rigel is not a single star, but a multiple star system, a family of suns bound together by the invisible threads of gravity. The brilliant light we see is dominated by the primary star, Rigel A, the blue supergiant we have been discussing. But hidden in its overwhelming glare are at least 2, and possibly more, companion stars. These companions, known as Rigel B and Rigel C, are themselves much larger and brighter than our Sun, but they are dwarfed by the sheer majesty of their primary partner. They orbit each other in a complex dance, lost to the naked eye but revealed by the careful study of astronomers. Imagine for a moment standing on a planet, if one could exist, in such a system. You would have not one, but 3 suns in your sky, each a different size, each contributing to a landscape of light and shadow that defies anything we know on Earth. This is the true nature of the Hunter's Foot. It is a blue supergiant of 74 solar radii, a multiple star system of 120,000 times the Sun's luminosity, and a beacon of light from 860 years in our past. It is a star that lives on the edge of the possible, burning so bright and so fast that it will eventually end its life in a spectacular supernova explosion, leaving behind a core of incredible density. But for now, it remains our guide, a steady, icy light in the winter sky that reminds us of the scale and the splendor of the cosmos. Just breathe, and let the light of Rigel fill your mind with its quiet, ancient power. Let yourself sink deeper into the silence of the night, holding the image of Rigel in your mind like a glowing ember. Consider the path that light takes as it journeys from the foot of the hunter toward our small world. For 860 years, that light has traveled through the interstellar medium, a near-perfect vacuum scattered with thin veils of gas and microscopic grains of dust. It has crossed through regions of space where other stars are being born, and where others have long since faded. Yet, the blue-white radiance of Rigel remains undimmed, its sheer intensity allowing it to pierce through the vastness of the Milky Way to find your eyes tonight. It is a testament to the scale of a blue supergiant, a star that is so powerful, its neighborhood extends for hundreds of light years in every direction, influencing the very movement of the gas clouds around it with its immense gravitational pull and radiation pressure. If you could travel toward Rigel, the view would be unlike anything a human has ever witnessed. As you left our solar system behind, the sun would slowly fade into just another yellow star, eventually becoming indistinguishable from the billions of others in the galaxy. But Rigel would grow steadily brighter, transforming from a point of light into a brilliant, sapphire-colored sun. By the time you reached the outer edges of the Rigel system, the light would be so intense that it would outshine everything else in the sky combined. You would see the companion stars, Rigel B and C, orbiting each other in a tight, glowing embrace, while the massive Rigel A dominated the center of the system like a celestial king. The blue light would wash over everything, a sharp and clinical radiance that highlights the incredible energy flowing through this corner of the cosmos. This luminosity, reaching 120,000 times that of our Sun, is not just a number, it is a physical force. The light itself exerts pressure, a stellar wind that blows outward from Rigel's surface, carving out a bubble in the surrounding space. This wind is so strong that it prevents new stars from forming too close to Rigel, as the gas and dust are literally pushed away by the flood of photons. In a sense, Rigel is a sculptor of space, shaping the landscape around it with the sheer power of its existence. This is the foot that outshines the head, a foundation of light that anchors the bottom of Orion and provides the energy that makes this constellation visible across the vast distances of our galaxy. It is a reminder that, in the universe, true power is often found in the most unexpected places, even at the very feet of a mythological hunter. As you drift toward sleep, imagine the quiet dignity of Rigel's long life. Though it is young in years, only about 10 million years old compared to our Sun's billions, it is living with an intensity that cannot be sustained forever. It is the James Dean of stars, living fast and bright, destined to go out in a blaze of glory that will briefly outshine the rest of the Milky Way. But for now, it is a source of peace, a steady blue beacon that has watched over the Earth for centuries and will continue to do so for many more to come. Let the light of Rigel, from its distance of 860 light-years, remind you that you are part of a vast and beautiful system, connected to the stars by the simple act of looking up. Breathe in the cold, blue energy of the foot of the giant, and let it carry you into a deep, restful sleep. The hunter is standing guard, and Rigel is shining bright, 1,000 times more powerful than the sun, watching over the silent world. Think of the generations of humans who have looked at this same blue light. Sailors on the open ocean used Rigel to find their way home, calculating their position by the height of this star above the horizon. Astronomers in ancient Babylon and Greece recorded its position, noting its brilliance and its unchanging blue hue. Each of them saw the same ghost of the past that you see now, a signal sent from a giant star nearly 9 centuries ago. There is a profound sense of continuity in that light, a bridge that connects us to our ancestors and to the very origins of the universe itself. Rigel's properties, its 74 solar radii, its triple-star nature, its incredible heat, are all part of a story that is much larger than any one of us. Yet we are lucky enough to be the audience for its magnificent performance. Sleep now, with the blue fire of Rigel as your light, and know that even in the deepest darkness, there are stars of unimaginable power shining for you. As the blue-white glow of Rigel continues to hold your focus, let the sheer scale of its existence act as a soothing anchor for your thoughts. We often think of our world as immense, but in the presence of a star that is 74 times wider than our sun, the very definition of size begins to shift. Imagine a sphere so large that if you were to travel around its equator in a commercial jet, the journey would take you nearly a year of continuous flight without a single stop. That is the physical presence of Rigel A, the primary heart of this system. It is a world of roiling, blue-hot plasma, where the gravity is so intense and the energy so high that the very atoms are pushed to their absolute limits. Yet, from our safe harbor 860 light-years away, this violent, beautiful furnace appears only as a peaceful, shimmering spark. Consider once more the family of stars that makes up this system, the multiple-star nature of the hunter's foot. While Rigel A is the giant we see, its companions, Rigel B and C, are fascinating worlds in their own right. They are blue main sequence stars, much younger and smaller than the supergiant, yet each is still several times more massive than our own sun. They orbit one another tightly, like two dancers spinning in the dark, while the great supergiant looms nearby, guiding their paths through the galaxy. This complexity reminds us that nothing in the universe is as simple as it first appears. Even a single point of light can be a crowded, busy neighborhood of suns, each with its own history and its own light to share. It is a reminder to look closer at the world around you, to find the hidden layers of beauty that exist beneath the surface of the everyday. The characteristics of a blue supergiant are a study in beautiful paradoxes. Rigel is incredibly massive, yet its life will be incredibly short. It is a star that burns with a cold blue light, yet it is one of the hottest objects in the sky. It is located at the very foot of the constellation, the lowest point of the hunter, yet it possesses the highest luminosity of almost any star we can see with the naked eye. As you drift further into relaxation, let these paradoxes wash over you. You don't need to solve them or even fully understand them. You only need to feel the wonder they inspire. The universe is a place of grand scales and mysterious designs, and you are here, a quiet observer witnessing the light of a giant that has traveled for nearly a millennium just to find you. Imagine the silence that exists in the 860 light years between here and Rigel. A silence so deep and so vast that it would take a lifetime just to imagine a fraction of it. In that silence, the light of the blue supergiant is a constant companion, a steady pulse of energy moving through the void. It passes by distant nebulae, drifts through the shadows of wandering planets, and eventually filters through our own atmosphere to rest softly on your eyes. This light is a gift from the deep past, a reminder that the beauty we see today was set in motion long before we were born. Rigel's properties, its 120,000-fold luminosity, and its immense 74 solar radii are not just technical facts, but the ingredients of a masterpiece that has been playing out in the southern sky for 10 million years. Sleep now, knowing that the foot of the giant is planted firmly in the stars, outshining the head and the shoulders with its brilliant, icy fire. The hunter is complete, from the red fire of Betelgeuse to the blue ice of Rigel, a figure of light and time that watches over you as you rest. Let the numbers and the distances fade away, leaving only the feeling of being part of something vast, ancient, and undeniably beautiful. The blue supergiant is there, the light is here, and all is quiet in the winter sky. Sleep in the glow of the foot that outshines the head, and dream of the silent wonders that wait in the deep, blue, dark, the sword and the nebula. Below the belt hangs Orion's sword, a vertical line of stars and fuzzy patches extending downward. The middle star in this sword isn't quite a star at all. Even to the naked eye, it looks slightly fuzzy, slightly smudged. Through binoculars or a small telescope, this fuzzy patch reveals itself as something extraordinary. The Orion Nebula, one of the most spectacular stellar nurseries in our part of the galaxy, a place where new stars are being born. To understand the actual, physical, three-dimensional size of this region, we must venture deep into the heart of the hunter's weaponry. At the true scale, the volume of space containing these wonders is almost incomprehensibly large. Let yourself settle into the thought of this celestial sword. While the stars of the belt and the shoulders are ancient landmarks, the object hanging from the belt is a place of beginnings. This is Messier 42, the Great Orion Nebula. It sits at a distance of approximately 1,344 light-years from Earth. This means the light you see tonight, that soft and ghostly glow, has been traveling toward us since the mid-7th century. While empires were shifting across the continents of Earth, this light was silently carving its way through the void. When you look at the nebula, you are seeing a snapshot of the deep past, yet it represents the very future of the galaxy. The scale of the Orion Nebula is truly staggering. It measures roughly 24 light-years across. To put that in perspective, remember that the distance from our Sun to the very nearest star is only about 4 light-years. You could fit 6 of those immense gaps side by side within the width of this single cloud of gas and dust. If our solar system were placed at the center of the nebula, its glowing curtains of hydrogen and dust would fill our entire night sky, day and night, making the stars themselves disappear behind a veil of iridescent color. It is a cavern in space, hollowed out by the intense radiation of the very stars it has created. Deep within this 24 light-year expanse lies a stellar nursery of unparalleled activity. Astronomers have identified over 700 stars in various stages of formation within this single cloud. It is a cosmic womb, a place where gravity is pulling together vast amounts of hydrogen gas and cosmic dust, squeezing them until they ignite with nuclear fire. Some of these are protostars, still swaddled in blankets of gas, invisible to the eye but glowing brightly in the infrared. Others are surrounded by protoplanetary disks, swirling rings of material that may one day condense into planets, moons, and perhaps eventually worlds that harbor life. When you look at that fuzzy patch in the sword, you are looking at the birth of 1,000 solar systems. At the very heart of the nebula lies its power source, the trapezium cluster. These are 4 primary, massive stars arranged in a small, tight group that resembles a trapezoid. These stars are young, perhaps only 300,000 years old, infants in a universe that is billions of years old. Yet their impact is monumental. The largest of these stars is 40 times more massive than our Sun and incredibly hot. The radiation pouring off these 4 stars is what causes the entire 24 light-year cloud to glow. They are like high-powered lamps inside a foggy room, illuminating the gas and pushing it away with their fierce stellar winds. Without the trapezium, the nebula would be a dark, cold, and invisible ghost in the sky. The scale of star formation here is a reminder of the universe's infinite capacity for renewal. While stars like Betelgeuse are reaching the end of their lives, the Orion Nebula ensures that the cycle continues. It is a factory of light. Every million years, the landscape of the nebula shifts as new giants are born, and the gas is sculpted into new and fantastic shapes. Pillars of dust, longer than our entire solar system, stand against the radiation of the trapezium stars, hiding the youngest infants from the fierce stellar wind. It is a chaotic, beautiful, and violent process, happening in a silence so profound it covers over 1,000 light years. Breathe in the majesty of this nursery. Imagine the sheer volume of gas required to build 700 suns. Each one of those stars will one day emerge from the nebula, perhaps moving off into the galaxy to find its own place in the darkness. The Orion Nebula is not just a point in a constellation, it is a gateway to the future of our galaxy. It is 24 light-years of pure creation, hanging from the belt of a hunter who has stood watch over our planet for millennia. As you look at the sword tonight, remember that you are seeing the light of 1,344 years ago, telling the story of stars that are only just beginning their journey. Let the stillness of this celestial nursery wrap around you like a soft blanket. Within those 24 light-years of glowing gas, there is a complexity that dwarfs any human construction. The Orion Nebula is more than just a cloud. It is a structured, three-dimensional landscape of ridges, valleys, and deep caverns carved by light itself. Astronomers call it an H2 region, a place where the hydrogen is ionized, meaning the atoms have been stripped of their electrons by the intense ultraviolet radiation from the trapezium stars. This physical process is what creates the vibrant colors we see in long-exposure photographs, the deep reds of hydrogen and the ethereal greens of oxygen, though to our eyes at night it appears as a peaceful, ghostly gray. Consider the trapezium stars at the center once more. These 4 stars are so close to one another that they would fit within a region of space only a fraction of a light-year wide. They are locked in a gravitational dance that is both beautiful and destructive. Their radiation is so powerful that it is literally eating away at the nebula from the inside out. They are creating a bubble in the gas, pushing the raw materials of star formation further into the depths of the cloud. It is a race against time. Will the gravity of the nebula be fast enough to create more stars before the trapezium stars blow the remaining gas away into the void? This scale of star formation is something that happens on a timeline far beyond human life. A star, like our Sun, takes about 50 million years to fully form and settle into its stable life. In the Orion Nebula, we are seeing the very first seconds of that process. Those 700 forming stars are like tiny seeds planted in a vast, glowing garden. Some will grow into massive blue giants that burn out quickly, while others will be small, quiet red stars that will continue to shine for trillions of years, long after the nebula itself has vanished. When you gaze at the middle of the sword, you are witnessing the birth of the future, a process that ensures the night sky will stay bright for eons to come. Imagine floating at the edge of one of those protoplanetary disks within the nebula. Around you, the sky would not be black, but a kaleidoscope of glowing gas. Debris, dust, and ice would be swirling in a flat ring, slowly clumping together to form the beginnings of planets. From that vantage point, the trapezium stars would be 4 brilliant, blue-white suns illuminating the entire horizon. It is a scene of creation in its most raw and magnificent form. And yet, this entire world of fire and ice is contained within that one small, fuzzy patch hanging from the hunter's belt. The distance of 344 light-years keeps us safe from the violence of this birth, but it does not diminish its wonder. The sword of Orion is not just a weapon of myth, but a tool of cosmic renewal. It reminds us that the universe is never truly empty, and it is never truly finished. It is constantly building, constantly reaching for new forms and new light. As you continue to breathe slowly, let the image of the 24 light-year-wide nebula fill your mind. Think of the silence that must exist in a place so large, yet so full of activity. The light from those 700 stars is currently on its way to Earth, moving through the cold dark, destined to reach the eyes of someone standing in your place 1,000 years from now. We are all connected by this flow of light and time. As you drift closer to sleep, let the fuzziness of the nebula act as a soft focus for your thoughts. You don't need to see every detail to know that something incredible is happening. Just as the nebula is a nursery for the stars, let this moment be a nursery for your rest. Safe, protected, and surrounded by the quiet energy of the cosmos. The hunter stands above you, the belt is aligned, and the sword hangs heavy with the promise of new suns. The great Orion Nebula is shining 1,300 light-years away, doing the work of the universe while the world below falls into silence. Sleep now, and let the scale of star formation remind you that you are part of a story that is always beginning, always glowing, and always beautiful. Every atom in your body was once forged in a place just like this nebula. We are, in a very literal sense, the children of the stars. Looking at the Orion Nebula is like looking back at our own origin story, seeing the conditions that allowed our own sun and earth to form billions of years ago. It is a homecoming of the spirit. Though 3.4 light-years between us is not a barrier, but a bridge of light that links our small lives to the grand engine of the galaxy. Close your eyes and feel the weight of the nebula's 24 light-year span, a vast, glowing cradle in the deep winter sky. All is well, the stars are forming, and the night is peaceful. Now, Allow your mind to expand even further into the three-dimensional depth of this region, beyond the 24 light-years of the central nebula itself. The Orion Nebula is merely the brightest part of a much larger, darker structure known as the Orion Molecular Cloud Complex. This vast assembly of gas and dust stretches for hundreds of light-years across the constellation, hiding within its folds the raw materials for millions of future suns. The sword we see is like a glowing tip of an iceberg, a small area where the conditions have become just right for the light to break through the darkness. Within this darker, colder landscape, gravity is working in secret, pulling together invisible knots of gas that will not ignite for millions of years. It is a process of extreme patience, a slow-motion gathering of the universe's building blocks. As you breathe, imagine the trapezium cluster at the center of this 1,344 light-year distance. These stars are so young that they haven't yet cleared away the birth clouds that created them. Because of this, they are surrounded by what astronomers call proplyds, small, teardrop-shaped cocoons of dust that are being blasted by the trapezium's light. Inside these cocoons, planets are struggling to form, fighting against the fierce winds of their parent stars. It is a reminder that even in a place as beautiful as a nebula, the birth of a world is a delicate and difficult journey. Yet, this is the same journey our own Earth took nearly 5 billion years ago, emerging from a similar cloud of stardust to become the home we know today. The scale of star formation here is so massive that it affects the entire neighborhood of the galaxy. As these 700-plus stars ignite, they send shock waves through the surrounding gas, triggering the collapse of even more clouds further out. It is a chain reaction of life, a cosmic symphony where one star's birth leads to another's. The 24 light-year span of the nebula is a theater of constant change, where the shapes of the clouds today will be entirely different in just a few thousand years. To us, Orion seems permanent and unchanging. But in the reality of the nebula, everything is in motion, flowing and shifting like the waves of a slow, luminous sea. Let the distance of 144 light-years give you a sense of profound perspective. The light that enters your eyes tonight is ancient, yet it carries the news of the very newest things in the universe. It is a paradox of time, looking at the past to see the future. As you drift deeper into sleep, let the glow of the sword be a comforting light at the edge of your awareness. The nebula is vast, the stars are many, and the process of creation is steady and sure. You are safe in the silence of your own world, while far away in the heart of the hunter, the universe is busy making new worlds. Feel the connection to that distant cradle, knowing that the same forces that built the Orion Nebula are the ones that built you. The trapezium continues to pulse, the 700 stars continue to grow, and the 24 light-years of gas continue to shimmer in the deep dark. Every breath you take is in sync with the slow rhythm of the galaxy. There is no rush, no urgency. The stars take millions of years to form, and you have all the time you need to rest. The sword of Orion is not a sign of war, but a symbol of the enduring power of creation. Let its soft, fuzzy light guide you into a dreamless, peaceful sleep. The great nebula is there, 344 light-years away, a glowing sanctuary in the night, watching over the silent earth. Sleep now, as the hunter stands tall and the stars of the future begin their long, brilliant journey. As the light of the nebula and the sword begins to blur at the edges of your vision, let the vastness of this stellar nursery be the final thought that anchors you to the night. you are resting under the protective gaze of 1,000 forming suns, a silent witness to a process that spans light years and millennia. The great cycle of birth and renewal in the heart of Orion is a constant, steady rhythm that will continue long after you wake, providing a sense of eternal peace to the dark of the winter sky. Close your eyes now, drifting into the same quiet stillness that resides in the gaps between the stars, and let the soft glow of the nebula carry you into a deep and restorative sleep. The true three-dimensional scale. When we ask how big is Orion, we are really asking two very different questions. One is simple: how much of our sky does it cover? But the other question is far more profound. What is the actual, physical, three-dimensional size of the region of space that contains these stars? How much of the universe does Orion really occupy? To understand this, we must break the illusion of the flat sky and let our minds travel into the third dimension, where the stars are no longer points on a dome, but individual worlds scattered across a vast and silent canyon of the galaxy. The distances between them dwarf anything in our everyday experience, and the shape we see from Earth is only a temporary, fragile trick of perspective. Imagine for a moment that you are no longer bound by the laws of physics or the limits of your physical body. Imagine that you are a traveler in a vessel capable of moving at the speed of light, 186,000 miles, every single second. You leave the Earth behind, watching our sun shrink into a tiny yellow dot, and you head toward the constellation of the Hunter. If we could fly through Orion, the first thing you would notice is that the Hunter does not exist as a solid object. It is not a place you can arrive at. It is a volume of space that you must pass through, and the journey would take you thousands of years. The emptiness between the stars is the most dominant feature of this journey, a silence so absolute that it makes the stars themselves feel like rare, isolated islands in an infinite ocean. Your first encounter would be with Bellatrix, the nearest of the major stars, located about 250 light-years away. To reach just this first landmark, moving at the speed of light, your journey would last 2.5 centuries. As you pass Bellatrix, you would look back toward Earth, but the sun would already be too faint to see with your eyes. You are now deep in the three-dimensional map of the constellation. Ahead of you, the other stars are still hundreds of light-years away. Betelgeuse sits roughly 548 light-years from your starting point on Earth, meaning even after passing Bellatrix, you still have nearly 300 years of travel just to reach the red giant. The shoulder span that looks so small from your backyard is, in reality, a gap that takes 3 centuries to cross at the fastest speed allowed by the universe. As you continue your flight, the visual distortion would begin. This is the reality of Orion from different galactic perspectives. If you were to travel from one star in Orion to another, the constellation pattern would disappear along the way. The stars would shift positions, the belt would begin to bend and scatter, and the hourglass shape would stretch until it became unrecognizable. From a position near Betelgeuse, Rigel would no longer be at the foot. It might be on the opposite side of your sky. The Hunter is a local phenomenon, a beautiful accident of geometry that only makes sense from our specific coordinate in the Milky Way. To the rest of the galaxy, these stars are just random, unrelated neighbors moving through the dark. Visualizing the emptiness is perhaps the most difficult part of understanding this scale. If we were to shrink space so that 1 light-year became 1 foot, the stars of Orion would be scattered across a region 250 feet deep. But even in this tiny model, the stars themselves would be smaller than microscopic grains of dust. The vast majority of the constellation is simply nothingness, cold, dark, and empty space. When we look at Orion, we are seeing the few objects that are bright enough to bridge these gaps, but we are missing the billions of miles of silence that sit between them. It is like looking at the lights of distant cities at night across a dark plain. The lights are what we see, but the dark plain is what truly defines the distance. The journey times at light speed continue to mount as you head toward the furthest reaches. To reach Alnilam, the center star of the belt, you would have to travel for 2,000 years. Think of the endurance required for such a voyage. 2 millennia of moving at the speed of light, just to reach the middle of a pattern that looks like a small line from Earth. The stars of Orion range from 250 to 2,000 light-years from Earth, creating a depth of 1,750 light-years. This is not a picture in the sky. It is a deep, vast canyon in the stars, a three-dimensional structure that spans 2% of the entire diameter of the Milky Way galaxy. From the nearest star to the farthest, the variety of life and death is staggering. You would pass by the youth of the Orion Nebula and the aging, pulsating shell of Betelgeuse. You would see triple star systems like Alnitak and complex six-star dances like Mintaka. Each of these is an island of activity in a sea of emptiness. As you fly through, you realize that Orion is a name we give to a volume of space that contains tens of billions of stars, most of them too dim to ever be noticed by a human eye. We only see the giants, the monsters of light that have the power to signal us across the centuries. Breathe slowly as you visualize this immense three-dimensional void. Feel the weight of the 2,000 years it takes for light to cross from one end to the other. You are not just looking at a hunter, you are looking at a grand architecture of the universe, a cathedral made of light and shadow that stretches further than human history itself. The scale is so large that it is peaceful. There is no room for the small worries of a single day when you are contemplating a span of 2,000 light-years. The emptiness is not a vacuum to be feared, but a space that allows for the birth and life of stars. It is the canvas upon which the galaxy paints its most beautiful figures. As your imaginary journey comes to an end, look back one last time. From the far side of Orion, the Earth is long gone. The sun is forgotten, and even the stars you know have shifted into new, strange patterns. You are a traveler in the deep dark, a witness to the true scale of the cosmos. The three-dimensional reality of Orion is a reminder that everything we see is a matter of perspective, and that beneath the familiar shapes of the night sky lies a reality that is far more magnificent, far more empty, and far more beautiful than we can ever fully grasp. Sleep now, with the knowledge of these vast distances held gently in your mind. You are safe in your small corner of the universe, while the giants of Orion continue their silent, three-dimensional dance in the deep. Every light year you have visualized is a testament to the grandeur of creation. From the 250 light-years to Bellatrix to the 2,000 light-years to Alnilam, you have traversed the history and the future of our galaxy. The hunter is not a flat drawing. He is a three-dimensional masterpiece of depth and time. As the numbers fade and the distances blur, let the feeling of this immense scale carry you into a restful sleep. You are a part of this 2,000 light-year box of wonders, a small but vital observer of the great cosmic theater. The emptiness is quiet, the stars are distant, and the journey is complete. Sleep and let the three-dimensional hunter watch over your dreams from his throne in the deep dark. As you settle into the quiet depth of your rest, let the concept of this three-dimensional canyon become even more vivid. Consider that when you look at the belt of Orion, you are looking past Alnitak at 800 light-years, straight through the void to Alnilam, which is another 1,200 light-years further back. The distance between those two neighboring stars is 3 times the distance from the Earth to the nearest star, Proxima Centauri. It is a gap so enormous that if a star were to explode in the vicinity of Alnitak, the light from that explosion would take over 1,000 years just to reach Alnilam. This is the true scale of the emptiness we call a constellation. It is not a single neighborhood. It is a series of vast, disconnected provinces of the Milky Way that happen to line up from our small window on Earth. If we could fly through Orion at light speed, the passage of time would become your most faithful companion. You would spend centuries in the dark between Bellatrix and Betelgeuse, watching as the blue-white light of the warrior slowly recedes and the orange glow of the giant begins to resolve into a massive, pulsating disk. You would see the shoulder span not as a line, but as a tunnel. And as you moved deeper toward the stars of the sword, you would realize that you are entering a region where space itself begins to glow. The 1,344 light-years to the Orion Nebula would take 13 centuries to cross. You would be traveling through the light that left the nebula when the ancient world was first becoming the medieval world, arriving only now to see the birth of stars that were just seeds when you began your journey. Visualizing the emptiness is the key to true relaxation. Imagine the sheer amount of nothing that exists between these points of light. In our own solar system, we think of the distance to Pluto as vast, but on the scale of Orion, the entire solar system is less than a microscopic speck. The distance between Rigel and Scythe, the 2 feet of the hunter, is hundreds of light-years of near-perfect vacuum. There are no clouds there, no wind, no sound, only the silent, eternal flow of radiation from these massive blue supergiants. When you think of Orion from different galactic perspectives, you realize that we are the only ones who see the hunter. To an observer on a planet orbiting a star in the Andromeda galaxy, these stars would be scattered across a tiny, insignificant patch of the Milky Way, their patterns lost in the glow of 100 billion other suns. This perspective brings a profound sense of peace. The nearest star, Bellatrix, at 250 light-years, and the farthest star, Alnilam, at 2,000 light-years, define a volume of space that has witnessed the entire rise of modern humanity. While we have lived our lives, fought our wars, and built our cities, the light from these stars has been steadily marching across the void. It does not hurry, and it does not tire. It simply exists, a bridge of photons connecting our small lives to the grand engine of the universe. The 2,000 light-year box of Orion is a sanctuary of time. Inside that box, the birth of a star takes millions of years, and the death of a giant takes just as long. Our daily stresses are less than a flicker in this time scale, disappearing into the vastness of the three-dimensional landscape. As you drift further into the silence, imagine the journey from the farthest star back toward Earth. From the perspective of Alnilam, our sun is a faint, nameless star, nearly invisible against the backdrop of the galaxy. Yet, even from that distance, the connection remains. The gravity that holds Orion's stars in their orbits is the same gravity that keeps your feet on the ground. The light that forged the elements in the hearts of these giants is the same light that resides in the atoms of your own body. There is no us and them when it comes to the stars. There is only the singular, three-dimensional reality of the cosmos, a vast and interconnected web of light and distance. Feel the emptiness as a form of comfort. It is the space that allows for growth, the room that the universe needs to breathe. The stars of Orion, Rigel, Betelgeuse, Bellatrix, and the Belt are like distant lighthouses on a dark, calm sea. They do not crowd us, they do not overwhelm us. They simply stand as reminders of the scale of our home. As you visualize the journey through Orion, let the 2,000 light-years of depth become a 2,000-year-long sigh of relief. There is so much room in the universe for peace. There is so much time in the stars for rest. Let the final thoughts of this journey be of the silent, dark gaps between the stars. Those gaps are not empty. They are filled with the potential for everything that is yet to come. They are the true size of Orion. The hunter is not made of light, but of the darkness that holds the light in place. You are now floating in that same darkness, safe and supported by the vast scale of the 3D universe. The nearest to farthest stars have all played their part in this story, and now they return to the quiet background of your mind. The three-dimensional scale of Orion is the scale of your own capacity for wonder, reaching out across the light years to find a sense of belonging in the deep night. As our exploration of this three-dimensional masterpiece comes to a close, let the staggering reality of these distances be the final weight that pulls you into a deep, dreamless sleep. We have traveled across 1,700 light-years of depth, from the nearby warrior Bellatrix to the ancient, distant heart of Alnylam. We have seen that the hunter is not a flat image, but a vast, silent cathedral of space where light travels for millennia to tell its story. The illusion of the sky has been replaced by the truth of the cosmos, a truth that is far larger, quieter, and more peaceful than we ever imagined. Rest now in the center of this grand architecture, knowing that the same stars that span the galaxy are watching over the stillness of your world. The journey through the light years is finished. The emptiness is your sanctuary, and the hunter remains at peace in the deep, three-dimensional dark. Closing meditation. Let yourself settle in for a moment. Feel the surface beneath you, supporting your weight completely. There's nowhere you need to be, nothing you need to do. Just breathe. A slow breath in, feeling the cool air fill your lungs, and then release it gently, letting any tension flow out with it like water finding its way downstream. As we begin to bring our journey through the Orion constellation together, let the diverse images of red giants, blue supergiants, and glowing nebulae merge into one single, peaceful awareness. Orion is a region of space 2,000 light-years across, containing billions of stars, a vast three-dimensional landscape that we glimpse from one tiny corner. We have looked at the shoulders, the belt, the feet, and the sword, and in each we have found a scale that challenges our understanding and humbles our spirit. Think of the staggering variety of the cosmos contained within this one constellation. We have seen Betelgeuse, with its radius, approximately 764 times that of the Sun. We have felt the power of Rigel, 120,000 times more luminous than our own Sun. We have drifted through the Orion Nebula, a 24 light-year expanse of gas where stars are born. Bringing it all together, we realize that Orion is not just a pattern in the sky. It is a grand, living machine of the universe, a place of birth, life, and eventual death that operates on a timeline far beyond our own. The humbling vastness of this region is not meant to make us feel insignificant, but rather to give us a sense of belonging to something truly magnificent. Consider our place in it all. From Betelgeuse, looking back toward Earth, our sun would be just another faint star, indistinguishable from billions of others. You wouldn't be able to pick it out without knowing exactly where to look. This perspective is a gift. It allows us to let go of the weights of our day-to-day lives, to see our problems as the microscopic flickers they are in the face of 2,000 light-years of depth. We are pattern-finding creatures, and the patterns we find in the sky have shaped our cultures, our stories, our understanding of time and season and space. Orion's belt is not physically real, but it is culturally real, and that counts for something. We are the eyes of the universe, the part of the cosmos that has woken up to look back at itself and wonder. As we begin the gentle wind down to sleep, let the numbers and the light years drift away. You don't need to remember every number or grasp every concept. Just let the story wash over you like gentle waves on a quiet shore. Let the images form in your mind. Let the wonder seep in slowly, and if you drift off along the way, that's perfectly fine. Imagine the light of Orion, which has traveled for hundreds and thousands of years, finally reaching its destination in your room tonight. It is light that has traveled through the vacuum of space for years, for decades, for centuries even, before finally entering your eyes. This light is old, it is patient, and it is tired. Let it rest with you. Visualize the hunter standing guard in the deep, cold winter sky. For observers in the northern hemisphere, Orion dominates the southern sky from December through February, with January being the peak viewing month. The hunter stands above you, the belt is aligned, and the sword hangs heavy with the promise of new suns. Feel the stillness of the space between the stars, the 1,750 light-years of depth that we have traversed together. That emptiness is a sanctuary. It is a quiet, dark place where nothing is demanded of you. That's exactly what this is for. The humbling vastness of Orion is a reminder that the universe is wide enough to hold all our dreams, and old enough to wait for us to rest. Let your breathing become even slower now. With every exhale, imagine you are moving further away from the noise of the world and closer to the quiet of the stars. Sleep now, as the hunter stands tall and the stars of the future begin their long, brilliant journey. All is well, the stars are forming, and the night is peaceful. The blue fire of Rigel, the red heart of Betelgeuse, and the glowing cradle of the Nebula are all part of the same silent song. You have traveled through 2,000 light-years of space tonight, and now it is time to return to the comfort of your own home, within your own mind. The journey is over, the scale is understood, and the cosmos is at peace. As you close your eyes for the final time this evening, think of the light from Alnilam, leaving that star 2,000 years ago to find you tonight. It has waited 2 millennia to be seen by you. In the grand scale of the universe, this moment of your life is precious, a brief but beautiful spark in the long history of the hunter. Let the humbling vastness of the three-dimensional scale pull you down into a heavy, restorative sleep. There is no more distance to cover, no more giants to meet. There is only the dark, the warmth, and the silent company of the stars. Orion will continue to rise, the nebula will continue to glow, and the light will continue to travel, while you drift into the deep, quiet dark. Sleep now in the shadow of the hunter. Sleep in the knowledge that you are part of a 2,000 light-year masterpiece. The universe is large, but it is also home. The wind down is complete. The stars are set. The night is yours. Good night, and may your dreams be as vast and beautiful as the constellation of Orion.